Today I'm going to do an introductory video introducing the basics of so-called magic squares. I get a lot of questions about this topic. They're very important in the Islamic occult sciences, but I'm not going to talk about anything occult or hidden or secret because occult and secret things should remain so. I'm going to only deal with the mathematics of magic squares, as they're called in English, and show you how to sort of start out playing with them if you like. And I should say that the term magic square is the term used in the English language. In Arabic, there's no such word. The word for magic in Arabic is sihr, and the word sihr is not used in reference to these what really are kind of mathematical talismans or amulets, or many Islamic amulets or talismans have a mathematical dimension or an element to them, and that typically involves such squares. The term in Arabic is wifqun, plural awfaq, wifq, awfaq, and that carries the sense of a kind of harmony, or a mathematical or numerical or arithmetic balance and harmony, because they represent grids. And so I've put a bunch of grids here, and you can notice that each grid is a square, obviously, and there's 3 little squares on each side, so there's a total of 9 in each grid. And even though in Arabic we use the term wifq, because I'm speaking English, I'm going to say magic square because that's the general term, but I'm in no way endorsing what is called magic or sihr. So when you have these magic squares, the smallest that you can have is the 3 by 3. And in Islamic occult sciences, the most important of such squares are 3 by 3, 4 by 4, and 5 by 5. I think today I'm only going to talk about the 3 by 3. If I have time, I might record some other videos. If you like this, if you're interested, please indicate that in the comments, and I'll make some additional videos explaining these. So again, the smallest you can have is a 3 by 3. And what happens is that in this square array of numbers, a bunch of numbers will be filled in a very specific order that preserves an extremely important mathematical property, which means that we'll fill in the numbers here such that no matter how you add them up, whether you add up the numbers in a vertical column or in a horizontal row, or on either the left or the right diagonals, they will add up to a single number. Now, these have been extensively studied in mathematics as well, and they call that number, mathematicians anyway, call that number the magic constant. And so we'll just use that by way of convention. So since there are 3 by 3, that means there's a total of 9. So the simplest way we can fill them in is put the numbers 1 through 9 into the magic square. Now, you can't do this. No, this is not how it's done. That is the wrong way to do it. So for example, the first row going across will be 1 plus 2 is 3 plus 3 is 6. Then here you'll have 4 plus 5, which is 9. 9 plus 6 is 15. And then you'll have 7 plus 8, which is 15. Plus 9 is, anybody know? 24. That's not how it's constructed. So the simplest so-called magic square has the numbers 1 through 9 arranged in it such that the magic constant is 15. In other words, no matter how you add it up, whether vertically, horizontally, or diagonally, you get 15. And so the simplest one is to put number 1 here. That's number 1. Then if you play chess, you use the so-called knight's move, and you go up and to the right, and you put your 2. Then you go over here and down, and you put in a 3. Now we're kind of stuck. So you go up here, and you have 4, 5, 6 down the diagonal. And then you have 7 over here. Then you will have 8, and you will have 9. Now let's inspect this. We have more room on this side, so let's just say 2 plus 9 is 11, plus 4 is 15. All right? We don't really have to put in an equal sign. So we're just showing that this adds up to 15. And you can, it doesn't matter which order you go. You can go left to right, right to left, because you'll still have the same numbers. And as we say in arithmetic, changing the order of the addends does not change the sum. So here's 7, 3, and 5. That also adds to 15. So you can see easily that 7 and 3 is 10, plus 5 is 15. Then here, obviously, you have 9. So you have 8 plus 1 is 9, plus 6. That's also 15. Let's go vertically. 4 plus 3 is 7. 7 plus 8 is 15. 9 plus 1 is 10, plus 5 is 15. 2 plus 7 is 9, plus 6 is 15. Let's do the diagonals. 4 plus 5 is 9, plus 6 is, put an arrow here, 15. 2 plus 5 is 7. 7 plus 8 is, diagonal sum is also 15. All right, so that's the first sort of configuration. And each of these configurations has a symbolism, which I will tell you at the end. So I don't want to get this wrong, so I'm just looking on this paper here. So what I do usually is, what I tell people is just memorize one of them. And so I memorize this one, and then you can easily derive the other ones, but we don't want to make a mistake while we're making the video. So if we move the position of the 1, so let's say from here, we move it to where the 7 is. So then we have the 1 in this position. Then our 2, if we use the knight's move, would be here. And then that changes the position of the 3 to down here. Now again, when you get to 3, you have to deal with the diagonal. So that's always, marker isn't really cooperating. 4, 5, 6. Need maybe a darker color. Let's just use black. 4, 5, 6, 7 goes here. And then you'll have 8 and 9. And you can verify that we really have the same configuration. We don't have to do the symbols again. It's just rotated counterclockwise, just ever so slightly. It's just rotated this way. So you see you have 1, 9, 5, like we had 1, 9, and 5 here, or 1, 5, 9, and so everything is the same. Now if we move the position of the 1 again, and we put it here on top, what does that do? So that gives us the 2 would be down here. Yes, then the 3 will be here, and again we'll have 4, 5, 6. 7 will go down here. And 8 would be here, and 9 would be here. Now you may have noticed by now that the corners are always even numbers. If you look here, you have a 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. And 5 is always in the center. And then the odd numbers are always on the middle pieces, or you could maybe call them edge pieces, for want of a better name. And so notice here we have 1, 3, 9, and 7, and 5 is in the center again. 1 and 3 and 9 and 7, 5 in the center. 1 and 3 and 9 and 7 and 5 is in the center. So what's our final possibility? Well, we've gone all the way around, and so now we put the 1 here. And when we have the 1 positioned like that, we go here, knight's move, we put in our 2. Then the 3 will be down here. And again, 4, 5, and 6 on the diagonal. And you can always remember, you know, about the rule about odds and evens. So if you put the 7 here, you know it's wrong because it's odd. It can't be in the corner. So you know 7's got to be here. So you know that 8 has to be here and 9 has to be here. And once again, we've got this configuration. So what is the significance of each of these squares? Each one, notice there's 4. Each one corresponds to one of the 4 elements. So if we go back here, the very first one we did corresponds to Earth. Corresponds to Earth, the Earth element. And then when you have the 1 in this position, this is air. When you've got the 1 all the way on the top edge position, it's fire. And then, so what do you think? This one is, well, obviously, it's got to be water. So each of these positions that has a symbolism, this square, this subsquare is associated with earth, this subsquare with air, the top subsquare, edge subsquare is fire, and then of course you have water. Okay, so what is typically done with these squares? I'm going to erase these to show you an example. Typically what is done is some sort of a divine name, for example, in Arabic is taken up and then it's encoded in the form of a number and then put into one of these squares. So I'll show you how to do that with a couple of examples. Let's hope it works. So the name for God in Arabic is Allah. So that's Alif, Lam, Lam, Ha. And usually this symbol is put here, indicating a doubled lam and a long vowel A. This breaks down into Arabic as the letter Alif, the letter Lam, and the letter Lam, and the letter Ha. 1, 2, 3, 4 letters. Now in Arabic there's a particular code or way of converting Arabic letters into numbers. And that's in the mnemonic Abjad, Hawaz, Hutti, Kaliman, Sa'fas, Kirshat, Thakhad, and Dalagh. That's written very quickly in cursive, bad cursive, I might add, Ruqa script. So this is a mnemonic device that helps you remember the order in which you do the numeric coding. So this is pretty well known to people who do these things, but many people who are watching this will not know. So let's do this properly. So then you have Alif, and I'm just going to make very, very simple kind of a very simple chart here. So you've got Alif. It's going to have to be a little bit small, so we've got to bring in the camera. Ba, Jim, Dal, Abjad. Then you'll have the Ha, Wow. And we better make this like this. Hawaz, Hutti. Kaf would be like this. Kaliman. We need to erase the divine name and we'll write it again because we've run out of space. Okay, so here, and I'm going to put the numbers in English, but these are the Arabic letters. So this is the number 1, 2, 3, 4, 5, 6, 7, 8, 9, and then at Ya, we count to 10. And you sort of cut it off here, 10. Now you start counting by 10, so this will be 20, 30, 40, and then 50. That should be 14 letters, so that should be half the Arabic alphabet. Kaliman. Then we have Sin, Sa, Ain, Fas. 1, 2, 3, 4. Qir, Shat, Thakhaz, Zal, Thakhaz. All right, so now what happens here? So you keep counting by tens. So here would be 60, 70, 80, 90. Now you count by hundreds. 100, 200, 300, 400, 500, 600, 700, 800, 900, and 1,000. You see? So this is how it works. So if you have the word Allah, okay, then this is Alif, Lam, Lam, and Ha. So what does that mean? Well, it means that Alif is 1, Lam is 30, this is 30, and this is 5. So what does that add up to? It adds up to 66. So now we want to encode the number 66 into this square. How do we do that? There is a complex mathematical formula that applies in the general case for any magic square from obviously 3, the minimum, up until however big one you want to make. But the simple rule for 3 by 3s is whatever number you have, first of all, it's got to be divisible by 3. If it's not divisible by 3, it doesn't work. You can tweak it a bit, but those are other techniques to force it there. Mathematically, there are ways of doing it. We're dealing with the simplest example here. So 66 is divisible by 3. So obviously you have to know a little bit of mathematics, and the Muslims who worked on these were really talented. I have Arabic manuscripts on this subject which are mathematically very sophisticated, but they don't use mathematical symbols like we do in modern mathematical notation. They explain what they were doing in words. So how do you do this? Well, what you need to do is you have to know what the smallest number is, where you start counting. So the smallest number in this is number 1, and it goes from 1 to 9. So you've got to figure out 9 numbers that you can somehow arrange in a harmonious fashion so that they all sum to 66 in the way that here everything summed to 15, vertically, horizontally, and diagonally. So the secret is that with the 3 by 3, you actually have to take whatever number you have and reduce it by 12. Reducing by 12 means you'll have 66, and you'll have 12, and you will minus it. You will subtract it. So you'll get what? 54. Then you divide 54 by 3. What's 54 divided by 3? Well, it's actually 18. If you don't believe me, you can check now. All you cheaters out there will be using your calculators. Don't do that. Okay? And you see you get 54. 8 times 3 is 24. Carry the 2. 1 times 3 is 3. Plus 2 is 5 is 54. So what does that mean? You see this quotient? That's the number we want. That is the minimum number. And you could take any of the squares that you want, but we'll just use this one, the so-called, this was Earth. And you put that number there at the Earth position. In other words, where the number 1 is. So here you will write 18. Now, you'll go to the 2 position, and you can use this one as your guide. The 2 position is here. And so what do? You increase it by 1. 19. The 3 position was here, so this will be 20. 4, 5, and 6 positions are diagonal, so you have 21, 22, and 23. Now, let's not get confused. So this was our 6, so the 7 position is here. So this has to be 24. The 8 position is here, so this has to be 25, and this has to be 26. So let's check it. 18, 19, 20, 21, 22, 23, 24, 25, 26. That should be right. Now let's see if we've done this correctly. Let's start here and do the verticals first. 21 plus 20 plus 25, so 1 plus 0 plus 5, 6. 2, 2, 2, 6. Let's do this here. 6 plus 2 is 8. 8 plus 8 is 16. You'd carry the 1, so you have 2 plus 2 is 4, plus 1 is 66. 9 plus 4 is what? 13. Plus 3 is 16. Put down the 6, carry the 1, so the 1 plus 1 is 2, then 2, then 2, 66. Wow. Let's go across. 21 plus 26 plus 19. So if you put the 1 over here, that's 20. 20 is 40. 40 plus 26 is 66. Let's do something like that here. So 20 plus 22 is 42. Plus 24 is 66. 25 plus 23, that's going to be 48. Plus 18, again, is 66. If you do the diagonals, you have 2, 4, 6. You have 60. 1, 2, 3. And that's 66. If you go here, you have the same situation. 19 plus 22, 22 plus 25, that's 47 plus 19 is 66. So that is quote unquote kind of magical in the just in the mathematical sense. So you've got this situation. So that's my example of the 3 by 3. So it's very simple to work with. And I think maybe I'll do another one on 4 by 4. It turns out that in a lot of Quranic theurgical practices, the 4x4 is favored because it represents a kind of balance with the 4 elements. A 3x3 is not always easy to fit things into, and the 4x4 is much easier. So we'll just conclude with that, and then maybe I'll do another video maybe on a 4x4 and then on a 5x5, and maybe give you the general equation if might be interest of people. So let me know what you're interested in, and put it in the comments, and we'll come back with another video, inshallah. Thank you.